Welcome everyone to FME and Transportation. As we get started, reminder, we're always looking for input from you guys for improvements that we can make, and we're always looking for new topics to discuss in FME and Transportation. No topic is too complex or too simple, so please, if there's anything you would like to share, feel free to contact me or Bo or Eric or John. So our agenda very quickly, we'll go through our group background and purpose, speaker introduction, presentation, and then we'll have Q&A and wrap up. I don't think we actually have polls today. So FME and Transportation is a special interest group with the purpose of curating and sharing success stories as well as best practices in applying safe software's feature manipulation engine, or FME, to the transportation sector. The creation of this special interest group was coordinated with the assistance of safe software and is meant to be vendor neutral. This special interest group was created with the hopes of unifying local governments, state-level DOTs, and the private industry, as well as serving as a holistic framework in which knowledge will be openly and actively shared via monthly presentations from community members and industry experts. These presentations will demonstrate and elaborate on real-world applications and success stories. Outside of the presentations, we hope this LinkedIn group will serve as a central repository for questions and answers as they relate to FME in the transportation sector. So today our presenter is John. John's my sidekick at Gistic. He is a project manager at Gistic Research. He has a master's in GIST and sits as a voting member on the GIS standards development groups through both the National Emergency Number Association and the AGIC 911 Committee. Additionally, John serves as an adjunct professor at Embry-Riddle Aeronautical University, where he teaches GIS. His favorite FME transformer is RGB geographic writer and XML storage trimmer. His least favorite food is pickles because he's obviously wrong. Pickles are delicious. And with that, I will hand this over to John and let him start presenting.
Great, thanks, Carol. Let me figure out how to get this up. All right. And in case any of you guys are wondering, the RGB geographic writer and the XMLX storage trimmer are not real transformers, but they really do sound like they could be. Carol, am I sharing the correct screen here? Do you see Journal Arcus?
Yes, I do see that.
Okay, great. So before we get started here, this is a pretty condensed version of what the WZDx format is. And I do see that we have Mark and Nate from the US DOT Volpe Center. So at any point, if I do butcher this, you guys can feel free to hop in here and give your authoritative view on what's going on. But our general process here was taking a ArcGIS REST service from the New York State DOT's Highway Oversize Overweight Credentialing System, what they call HOOCS, and taking the data from that and publishing this as an API in the WZDx format. And so as a general architecture, they have some internal processes that do a manipulation on this database, perform an ETL, and then they push this up to a REST service. Now, in this demonstration, I'm going to show you guys, I'm not actually using this live REST service. I'm using a data extract from that REST service, just because it's a lot easier to demonstrate this process quickly using the GeoJSON already local rather than having to retrieve it via a query. Now, the process really takes this GeoJSON extract. But again, this GeoJSON extract is exactly the format of an ArcGIS REST service query. It's just stored locally. The FME process can read this extract or read this REST service every few minutes and then save that the GeoJSON features in the WZDx format locally for retrieval. And then during this phase here, because of the specification, we also need to have a bunch of metadata, which I'll dive into shortly. And this is stored locally on the FME server as well. And then the next step here would be during this ETL process, we actually kick out records and can send them back for QC purposes. Records that don't meet the correct format requirements or are missing key information for the WZDx format. And then finally, the FME server has a published app interface where you can retrieve this GeoJSON WZDx format via an API. So these requests come in and it pulls this WZDx just right from the server rather than rebuilding it every time. So there's really two separate steps here. Loading the restriction feed onto the server by taking the HOOCS database, performing this ETL, and then storing that GeoJSON locally, and then retrieving that GeoJSON feed. That way, every time a request is made for that feed, it happens nearly instantaneously because it's already been built. And this is also not like this is always available because it's only ever overwritten every 5 minutes or every 3 minutes as the feed is updated, rather than having to wait for the the 30 seconds or the 40 seconds to build this feed here. So that's kind of the overall architecture that this system is using in the general design idea behind this. But now let's talk a little bit about what this actually is. For those of you, I think maybe half the people on this call are familiar with WZDx and the other half probably aren't, but it is a very specific feed called the work zone data exchange format. And there's multiple different types of the feed object. There are road restrictions, and there's also worker presence and a couple others. But in terms of what we're looking at, we're actually looking specifically for the road restriction feed inside of this this project here. And this was, I think Kevin Hunt is also on this call. I think he's a little under the weather, so I think he said he would, be only communicating via chat. But if you have questions on kind of the goal, I think he can elaborate. But New York was having issues with people crashing into bridges, and so part of getting this work zone data exchange format off the ground, someone had the idea that we could include these road restrictions. That way, these oversized trucks or these tall trucks stop crashing into bridges. Crashing into bridges and crashing into pretty much everything else, and not driving on lanes that were too narrow, too short, all of this sort of thing here. So inside of the road restriction feed, we have many different components. We have our feed info, and this is where that metadata geodatabase or that metadata info comes in from the server, because all of these features kind of have to be tagged. The feed itself has to be tagged, but then the features also have a metadata tag that links back to the feed info, as we'll see shortly. We also have a type. This type is just a GeoJSON object. It's always feature collection for this. So this one's pretty easy to build. Now the features are a very nested array structure that contain multiple layers of nesting, which anyone familiar with an ArcGIS REST service knows is not the format an ArcGIS REST service kind of delivers its data in. So this is really where the key component of this project came in, is figuring out how to take a single database object and converting this into this very nested structure that has relationships to this feed info object. And then the bounding box is exactly what it sounds like. Each feature has a bounding box, and then every feature itself creates an overall bounding box. So if we look at and we dive into these individual categories, we can look at that feed info object, and we can see that we have to have a name of a publisher, what organization's publishing this. We have to know what version, major and minor, of the WZDx format this is published in, the license of this, and data sources. So nothing too critical, but this data source is its own array, which is another nested series of objects, kind of listing every single data source that this object can come from. And so the idea behind this is that New York could publish this, New York DOT could publish this, but they might have data sources coming in from their sheriff's office or their police department or their fire department, or any of these sub-agencies within the state who have created this road restriction event. And so all of these things can be all of the events themselves can be linked back to a single data source. The next object here, no, there's more, sorry. So we have our update date, update frequency. So, how often in seconds is this updated? And then who can we contact to get more information about this feed? And then in terms of the data sources, I do believe I put this in here. Again, we can have another data source. And so we could say that, the sheriff's office published this and it's last updated, and it updates every 30 minutes until it vanishes from the feed. Or maybe there is, a wildfire, and so the Forest Service publishes something through your guys' feed. So there's multiple different agencies in this structure that could, in theory, publish this, and that's where this data source comes from. But this is just an example of how nested this data structure becomes, because we have our road restriction object, we have our feed info object, we have our data sources object, and then we've got properties of that. And so deriving this information directly from a feature is where things kind of get a little difficult. So next we have our road event feature object. The road event feature contains a unique ID, another GeoJSON property that's there by default. And then we have different properties. So is this a detour? Is this a work zone event? Or is this a road restriction event? And then each of these things generally share a common pattern, but they all do have, a little nuances to them. And then again, we have the geometry of the object and we have the bounding box. So that is not the end. Let me go ahead and pull up this. I just wanted to show everyone here on the call, we do have thorough documentation on GitHub. And when I say we, I should say the USDOT and Mark, I think you're actually on this call here. So I think I see your name right up here. You can find everything you could ever desire inside of this. And so we were looking at this road restriction feed. In this road restriction feed, again, we have our feed info, we have our type, our features, and our bounding box. And so if you were looking at your road event feature, you could come in here and look at all of the properties of your road restriction event and see your road event core details. And so you can see that you can kind of keep going down this chain, and there's quite a few layers of these nestings that are happening here. And then last thing I want to show before we actually look at the FME is this is what we're talking about, just an ArcGIS REST service coming from NYS DOT. And essentially what we're looking at here is this. So rather than using this query to build this and retrieve this query every single time, I just have this GeoJSON saved locally for use in this process, but we are using exactly this right here. So now we can go ahead and hop into FME. And it's not overly complex of a process to actually generate this, but we do have some general assumptions, including metadata in here. But you can see, we only have 31 transformers, a couple bookmarks, no custom transformers or anything. But we do have this broken down into the different components of the feed. So here we have our feed info. This is required. I forgot to mention that on the restriction thing, we have required and optional. So we do have components that don't have to be there, but could be there depending on the example. But then we do have components that are definitely required for this to work. And so that has been kind of baked into this as well, where some things are optional, and if they're present, will get flagged or get put in there. And if they're not there, then we can kick those back out. Pretty simple here. We have a CSV, and this is essentially our metadata, our dictionary, if you will. So if we had multiple different agencies and multiple different data sources, this is kind of the database they would reside in. So they have a publisher, contact name, contact email. In this case, it's Kevin Hunt, who's also on this call. The update frequency, the update version, and this is actually incorrect. This should have been 4.0, because this should be a major minor version. But for demonstration purposes, to see if we can actually build this feed, it's definitely all right. And then here we have an attribute creator creating our data sources, because the data sources are separate from the publishing agency. And so in this case, our data source and our publishing agency are linked by the data source ID. And each feature in this object would also be linked by this data source ID here. And this, we just put generic things in here. So first, last, comma for name and email. So there's no real specifics. The end goal of this is really creating that feed and seeing if we can take these features to the feed, because that's where the difficulty of this comes in. And the magic of this really happens inside of these JSON templators, which FME is really awesome. In this case, that we can kind of sub-template things out and create this nested structure. So here at the root level, we're just creating, the feed info object, and we're passing in the attributes from that feed info into an array down here. And then we have our data sources right here. And so we're actually taking the sub-template of data sources, and we're shoving that into the root template of that. And so what we end up with is this the very beginning of this JSON structure here. So we've created our feed info object, and then we've also created our data source object here inside of this feed. The next portion of this would be to actually create the features. And we do some kind of general assumptions based on the data we have and some field mappings we identified with New York State. But pretty simple. We keep the relevant attributes. We were testing only bridges in this case, so we have a tester to make sure we only have bridges. We have an attribute splitter, so we're splitting out these bridge names, then trying to capture the road names here. And so this setup right here is really just to find bridges and identify the two names of the bridges and split them out. That way we can identify what the main and the cross bridge are, or the cross streets. So identify both the direction of travel, or what road is carrying traffic and what road is crossing that traffic or going over or under that at the bridge. Here we're just renaming some list attributes. And then we are splitting the roads back out. And so we're creating the two separate road features. And then basically we're just testing whether it goes under or not. So does this cross the road? And eventually, again, this is just a parse out name, so I'm not going to go through this too much. But we end up creating this attribute here, whether this is the event type, the data source ID, what the road names are. And in this case, for this to be implemented in production, the data itself would have to be stored on the server with a data source ID, or a data source name and a lookup table. So if this came from another agency, we could dynamically link it back to what agency that is via a linkage table or a metadata table. Finally, we come up here and we start creating the bounding boxes. So we extract the geometry, and this is coming directly from its GeoJSON encoding. And then we create the bounding box. And then we found this issue. I'm not really sure, why this happens, but without this orienter, some things failed to validate in the GeoJSON templater whenever we were validating JSON. And for some reason, some of the GeoJSON objects returned by Esri were oriented in the incorrect direction. So instead of the clockwise or counterclockwise, they were flipped the wrong way. And so we have an orienter in here to make sure all of the objects are oriented the exact same direction, following this right-hand rule for the JSON conventions. And then we create the other bounding box. So, as I mentioned, the feature itself has a bounding box, and then every feature together has a bounding box. And so here we're creating individual bounding boxes, and here we're aggregating bounding boxes together to create one single bounding box. And then we are splitting our attributes out via our road names back into two separate attributes, and then doing the same thing that we did before, where we have this JSON templater. And so we have our root process or our root template, and this is just does nothing but calls the sub template of roads. And so we can process this on a feature by feature basis. And what we're doing here is getting a list of the roads here. And so this is really just creating that list, that roads array here. So listing all of the roads that were affected. And then this nested thing gets re-nested into another GeoJSON templater or JSON templater. And so here we have our restriction event, what the type is, the value, and the unit of the restriction. And then we have our core details. And both of these subtemplates get nested back inside of this root template. And so we're pulling the object ID of the feature, the type of the feature, and then we have our properties, which are calling that subtemplate of core details, and our restrictions, which are calling that subtemplate of our restrictions, and then the geometry in the bounding box. And so the output of this would be really the core component of that WZDx feed here, where we have at the feature level, we have our feature ID, our feature type, we have the properties, which include our core details, the event type of restriction, the data source ID, all of the road names of the afflicted roads, what direction of travel this is in, and then the restrictions that actually exist in here, being a reduced height with a value of 0 units of feet. obviously probably is not a reduced unit to 0 feet tall, but this just kind of shows you how we can begin to build these on a feature by feature basis. And then here we have the actual geometry of it. Then we have the bounding box of this all nested in that WZDx format. And then finally, once we have, let's see, I believe we're only keeping the necessary things here. Yeah, so once we have this, this GeoJSON result of each feature that belongs in the feed, and we have the bounding box that belongs in the feed, which is also just as a straight GeoJSON bounding box, and we have that original feed info, we can begin to take all of these separate JSON components and then re-nest them back together to get that finalized feed here. And so if we look at this final feed, we can see that it has all of the necessary components. And this is pretty cryptic. I'm not sure if this will make it out. So I have it pretty printed on the next steps. We can actually look at this kind of in a more user-friendly format. But here we have our general restriction object. Here's our feed info. Then we have our metadata is all through here, where we have our update date, publisher, contact name, contact email. Then we have our data sources array. And so we have our individual data sources that exist through here. And then we have our feature collection type. And then we actually begin to talk about all of our features. So these are the actual features we pulled from the REST server. Now, to make this process work on FME Server, we have to use the feature streaming service. And I found, David Runnels on this call. I know he is very, very skilled in FME Server, so he might have some thoughts on this. But I found the best way to write this out wasn't actually necessarily to a GeoJSON file, but actually writing this to just a straight text file. The text file didn't require any validation, and it didn't seem to pose any problems, and it made it very easy to read and write this. And so I am actually writing just a straight text file out of this, but the text file I'm writing out is named restrictions.geojson. So it is a GeoJSON formatted object with a GeoJSON extension, but it is with an FME considered just to be a text file. And then the next component to this, I think, as I mentioned in the slides, we have two components. We have loading the restriction feed, and then we have retrieving the restriction feed. So this process takes everything from the ArcGIS REST server, and it pushes it to storing locally on the FME server. And so once we have that GeoJSON stored on the FME server, it's a very simple call. So anytime someone hits the API, we read that text line file, and then we just stream it over to them immediately. So there's pretty much no delay whenever that API is called. And in this case, I'm going to pretty print this JSON so we can look at it really quickly. This tester really just says, was the parameter of pretty print equal to yes? And this was for my testing purposes, just so I can kind of look at this and validate the structure of it, a little easier than the nest component. And I am working over a WireGuard connection to a computer far away. And so it does take a minute for this to actually retrieve back to my computer. But here we can see that nested structure where we have our feed info, we've got our data sources, then we've got our feature collection, and then we have each of our individual features. So this is the entirety of feature 1. And then we have feature 2. And so this is essentially what we're able to build, starting with the ArcGIS REST server, where we have this information as a single attribute across the board. Now, the last component to this is showing this here. We do have 2 FME web apps just for testing purposes. And so let me retrieve this restriction feed really quick. And it should just take a second. So here we can see that we have our contact name and our contact email. And then our data sources here are first name, last name. Well, the idea behind this is that you can, in theory, change these things very easily. And in here, we're using, human input parameters. But if we had that metadata geodatabase, then whenever we rebuild this, it should be, we could pull that from, a standardized or authoritative geodatabase. This will probably take 15 to 30 seconds, depending on what the server is doing to rebuild this feed. So just bear with me. All right, that's pretty quick. And now if I come back and I rerun this process, we should see that, I updated the data source to be me, so now I am the authoritative data source for this feature collection. So this is the, the grand idea behind this process is we can take these ArcGIS REST services that are not anywhere near this WZDx format, and we can begin to generate these using FME Server and having, this API that any agency or any system can hit this API and return this GeoJSON in a matter of seconds. I think that's really the bulk of my presentation. I don't think I have anything else. If you guys have any questions, I do see some questions in chat that I wasn't able to look at while I was going through all that. But if anyone has any questions, please feel free to unmute and we can talk about this further.
I will say from my experience working with, what is it? I think we did like version 1.x, or maybe it was version 0.x. And when I was working with it in Iowa on the work zone data exchange feed, not the restriction feed, I definitely did run into a lot with the issues with building the nesting, having to go about it a convoluted way. And mine was, I think at that time, and I don't know if it still is, it was based in XML. So having to do everything in XML, there are some, okay, yeah. So as Nate said, version, I guess 1 was XML, and now they've, I'd say, made the better decision to go to GeoJSON. But what I found was, so how we did it was we pulled from our 511 feed and basically ripped out the start and endpoints and then a route identifier, ran it against our LRS to be able to get the true geometry of the road, along with some of the other, like the mile or the route measure and stuff, and other lane characteristic information. So I was definitely convoluted, and we pushed it out there as a, as I posted up there, an XML file on a web server for being able to do high availability. Because the other thing with this as well is, I guess, are you running it on are they running it on an FME server then, or?
So this isn't implemented in production. This is kind of a concept. But yeah, this is all built around FME Server. And so essentially, you would schedule the loading of the data to happen every 3 minutes, 5 minutes, or 1 minute, whatever you wanted. And then the FME Server would pull the objects from the ArcGIS server or whatever data source you're using, and then convert that to this GeoJSON, to the actual feed GeoJSON, and store that feed GeoJSON locally on the server. And then whenever the API endpoint was hit, it's a simple call, just reading that data, reading that WZDx feed from your server and streaming it out to the requester. Yeah,
I would say from a high availability standpoint, we kind of we did some KML type work like this in Iowa. And we started with it being hosted on FME Server, but then that time latency factor is a issue. And so being able to focus on how do you make it highly available. And the method that we did that was basically export it as or I guess use FME Server on a schedule and just upload it to a FTP or web server, and then have people hit that. Because really, unless it's dynamic, right? Unless you're allowing parameters to be passed in, there's not much of a use, I guess, to be able to, or there's not much of a need to be able to use the capabilities of FME Server and bog down your FME server to be able to serve out a file. I mean, maybe initially at first, but once it gets going, like we were imagining that a lot of, like, I guess in this case, a lot of truck vendors would be probably pulling this.
Yeah, and I totally agree with you on that. Especially if you only have one server engine, if the, if that engine is in use, then your API call is stuck in the queue here. So this would really have to be built on an infrastructure that had multiple engines, or even a couple engines dedicated to just pulling this feed and streaming that feed out. And so I do think that, retrieving the feed is just an example that we can do that here, but you're 100% correct. This would be better just from, anywhere else that doesn't require these engines to run this single process. The bulk of the FME process really happens whenever we're creating the feed itself, and where the end feed exists is really dependent on the use case and the need of it. But you make some very valid points as to bogging down the FME server, especially if you only have that one core engine running.
Yeah, I'll also throw in there too is I think I did it the same way, where using a text file, right? Because a text file doesn't do any of the validation stuff that all the other ones like to do.
Yep. I don't know.
Oh,
sorry, Eric, go ahead.
I was just gonna say I have a question when you're done.
Oh yeah, I was just going to say on that point, David, I found numerous issues with the WZDx feed not being validated whenever I wrote the GeoJSON writer. But if I were to plug in that WZDx feed directly on like a JSON validator online and pass the schema versus what I created, it validates 100% of the time. And I ran through this manually for the first 50 features or so and verified that everything was correct. So there was definitely something weird going on with the FME internal validations of the JSON schema. And that was part of why I had to use that orienter for the polygons as well. But I do think the text line writer was definitely the way to go for these kind of unknown schemas.
So a couple questions I have here. I remember working with David a little bit. David did all the work in Iowa, but what is a proper refresh frequency of this data? If you're putting out like a feature service and stuff, I'm just wondering from the community here, what would be a refresh of your services if you're not streaming?
Well, I think the idea behind this feed is that this is as near real time as you can get, because we're talking about not only routing for human people who are putting this into, say, Google Maps, but we're also talking about routing of autonomous vehicles in the future.
Right. So
this, I think that I've seen the last meeting I was in, someone even proposed like 30 seconds or a minute of refreshing of this data. And how that happens is, that's where the question comes in, is how do we, on a minute by minute basis, track where this worker is as he's striping the roadway.
Right.
So I think the idea behind this is as near real time as you can get, and beyond that, how that happens is a question that the community as a whole who is developing the standard is trying to address.
Yeah, because one of the struggles can be moving work zones, right? As you mentioned, paint striping, right? The work zone is actually traversing the network at a slow pace, and being able to do that. I don't know if on the feds on the phone, are there anyone doing real-time updates and streaming of this out there at the state level anyway?
That was a question for Mark and Nate, right?
Yeah.
I would rather hand it to Mark, but I can try.
I think they're mostly planned information and feeds right now, but I don't know all of them intimately enough to say that it's not happening somewhere, I guess.
Okay.
And I guess a more nuanced answer is, so take one of the data feeds that's up and available at the links you saw earlier is from the state of Colorado. And that's from their ATMS system. So it's mostly planned and slightly more real time than planned, but let's not call it real time. But what they're working to implement over the next few months is taking data from an automated truck mounted attenuator and piping it straight into that feed. And so that would be an example of real time. And I guess the only other thing to add is John showed the different feed types available, and he was talking about the restrictions feed. There's also another feed called Smart Work Zone Device, or SWZ device, which will in the next iteration just be device, since in theory most devices are smart and all that stuff. And those are real-time data coming off of ITS devices in the field, location devices, sensors, speed sensors, arrow boards, et cetera. And so there's a lot of back-end integration to be done with getting the device data and integrating it with more planned data, but that's kind of the future of where this is going. Thanks.
I guess building on that, of something that we ran into when we were initially doing the initial implementation at 1.0 was, especially on the work zone data exchange feed service side of things, how do you get accurate like on the taper and on the like where the start and end of the work zone is, right?
I would think that accuracy is.
I know that's a problem that like literally every single state has. And since the feds were on, I figured I'd ask them of like, is there, I know we can try the best, but I mean, even when you have like contractors that don't call up and they just close a lane of traffic down, right? Like,
Yeah.
there's other issues to address besides, or in addition to that, but
Sure.
if it's a DOT driven work zone, how do you capture that accurate information? Or do
Yeah,
you even do it of, is it gonna come from connected vehicles, right? Talking back and providing that data.
I mean, that's one potential answer, although the prevalence of those is still in the works. I think that the global answer is that accuracy is going to be the next kind of major phase of this larger effort, both getting these feeds more prevalent, but then improving their accuracy, which I think the device integration, using smart devices, using arrow boards, which are placed at specific places, and should give you a better sense of whether there's work happening and which specific lanes are closed because they're there. But obviously, there aren't going to be arrow boards at every work zone, and so it's not a perfect answer. So it is an issue. The first 3 or 4 versions of this project and effort have kind of focused on making this stable and usable and starting to get folks implementing it. And so I love what you're doing here, and it's really awesome. But yeah, the next phase is really going to be, okay, great. Now they're here. How do we know the information that's coming out of these feeds is actually useful? And some of that will be driven by the folks consuming them, whether that's vehicle manufacturers directly, whether that's mapping and navigation providers, your typical Google, Apple, Waze, et cetera, with folks, getting a note on their phone in their car that says there's a work zone coming up, left lane's closed, and they go in the work zone and the left lane's not closed, and they're like, excuse me, like this is a pain in the neck, right? So there's a certain amount of feedback loops that will hopefully help us close that gap, but it's definitely on the mind.
And I just want to say that's where, tools like FME and FME Server can help bridge that gap, right? I think eventually these work zones are probably going to end up coming out of different 511 type systems or who knows what, right? But FME right now bridges that gap. I think what John showed was really good, right? You can start bringing disparate data together. It may not be quote real time, but at least you're making those steps forward. And FME can be a great tool to help you at least get started and show the value of it.
This is Kevin.
I have a
It's
comment
interesting.
on the
started to have.
accuracy. If you hello, I think accuracy for work zone, and I'm assuming the intelligent, the autonomous vehicle, the computer vision is a major component of it. They cannot just blindly believe in any data feed in and using that to drive decisions solely. So I think in the transportation field, the accuracy isn't as important as the correctness in terms saying northbound, eastbound, how many lanes on the left and right. My personal experience, and just after JST was driving back to West Virginia, Charleston, and I was routed into a direction from Google to a stopped, essentially one-way stop, and saying the other direction is coming. I was baffled. I can't believe that I couldn't go. So in fact, I I ignore the message board, and because it's not really heavily trafficked. So I tried to go through and just to check that out. And later there was a second stop saying it's blocked. Then I realized, this might not be a kind of mistake. And then I thought, what am I going to do? The other option is going to cost me at least 1.5 hours getting back to Charleston. Then later it dawned on me, it must be the feed was wrong. The northbound, southbound being switched. Then I just came, when I realized that, I just drive to the location directly without listening to the Google's routing. And then I'll be done. 3 miles down the road, I see the other direction, the southbound direction being diverted rather than northbound direction being diverted. So I think the accuracy is more the correctness, more important rather than how many feet, starting and how, or ending of the work zone. So that's my personal reflection. The other thing I think from architecture perspective, and people keep thinking, talking about the interval, the refresh cycle. I typed in a few things on the in the chat window. And there are different technologies we can be used. And also we need to, I think what John demonstrated using FME is the core for parsing out the incoming data and making sure the outcome data meets the standard. And in the process, we do QA/QC and reject some things to remind people. I think that's the core of it. But in the application deployment, in the hosting deployment, we need to consider what the source data conditions are. There are some shops, they have ArcGIS server stand up. And in that case, the RESTful feature services are actually, they're not streaming services, okay? And so FME has to do multiple pull in certain sequence, frequency to update the data, because you do not know. FME have to pull, say maybe there has been a change. But if you have geo event server, and that's event streaming, then it will push information over to FME. So FME streaming, sending streaming will be quite easy. It's no longer needing to refresh, keep reading from the source. Then there are other shops, they simply do not have FME, do not have Esri implementation. Then the sources, the option is maybe we can dig directly into their database using FME. And that's going to need to be customized, right? Because you don't have a kind of standard kind of data format layer that we can tag on. And or the other option is writing a really small footprint server, could be a streaming server. It's not big deal, writing using Nginx and writing a simple Node.js server to serving the data from data source. So making sure that service, this little piece, the serving this data, having certain standard so that FME component can be still interface with a quasi-standard kind of like format to deal with it. So reducing the need for any customization on the FME side. So again, it's also possible that FME streaming services, each time you hit, it will serve live, it consume the engine. But it's also possible we can just spit out multiple copies, in different folders, I guess, keep the static file for easy pull. But with those files in maybe multiple locations, multiple folders being round robin, being updated in a certain cycle, and having a balancer to hit them to scale that up. So that's kind of what I'm thinking out loud. While John was presenting, I think there's some technology, some architecture pieces. When John and I designed this, we just assumed we're more focused on New York DOT's architecture and potential. But again, there are other places and how we can make this universal applicable. So some of the architecture potentials I'm just like to share with you, see if you have any comments on that.
Oh, I was going to say that the same thing. This is Kevin. It was interesting because Tim, who is already working with our 511 vendor on getting our work zone information, construction zone information into work zone data exchange format, that would presumably have the type of update cycle that has been mostly discussed here. The bridge data, that clearance data, is updated for our oversized overweight system once a day, overnight. And that comes directly from our structures management system, right? So those bridges are inspected each day, perhaps. And so that information is pretty dynamic, but really only updated in that system once a day. We rely on that oversized overweight system as a system of record for that geometry that John was pulling into the work zone data exchange format for us. So that's an example of, so two things there. One is we can provide information in work zone data exchange from the system of record for these different types of events on the network that we want to publish, and they can be at different cycles, and we could simply update work zone data exchange for clearances on a daily basis, as opposed to perhaps every 5 minutes for things happening on the system from our 511 system. So that's what we're looking at right now, and it doesn't, as long as using a format like this makes it easier to just say, okay, we're going to have the 511 vendor publish construction zones, and maybe they can do that for us, and maybe we're going to publish the structure clearances in a different work zone data exchange, and those can be consumed by our customers. And really, the end game here is to have the network, the navigation companies, beyond just the companies that serve the trucking community, incorporate this into their applications. So if you go to rent a truck, they kind of grab your, oh, you're going to use Google Maps? Okay, hang on a second. Let me just plug in the height of your vehicle into Google Maps for you, so that Google Maps is not going to give you a route that's going to have vertical clearance impedance in your path. That's really where we want to see all this go, and that's why we want to get as many people looking at work zone data exchange for vertical clearance as possible.
That makes sense.
I was going to ask John, I know I talked with you about this in the past, but for everyone else on, are you looking at release, or are you or is SAFE looking at releasing a writer for the works on data exchange format or something on the hub?
We did meet with SAFE about that, and Bo, correct me if I'm wrong here, but I don't think that they saw the need to have a writer, mostly because of the complexities of this GeoJSON. I think they pretty much felt that they could be done with all of the, a standard writer. It was really just formatting the data before writing it. And so formatting the data is where the challenge comes in. And I don't think that they planned on outright creating a writer for this, but that's, that would be definitely a question for them, and that could certainly change. And maybe Bo can jump in if I'm remembering that incorrectly.
Yeah, I remember having conversation with them, and later actually was my our reflection telling them it might not be really feasible and to create a separate format. I think at time rationale, I think majority of our work, the component is so much, the format itself in the future can change quite often, but it's getting the data prepared to feed into it. And I don't know how you can actually later I think the majority of the cost is on understanding the source data, knowing how to QA, QC, and then knowing, certain unit needs to be converted, right? And there's just many nuances it's the understanding of the data before moving over. Moving over, yeah, it's kind of complicated a little bit, but still FME's JSON templators and segmenters, what have you. Yeah, a little bit struggle, but it's not too bad at all in that sense. You struggle, but FME is so flexible. There's so many ways to do it. It's okay. I don't think it warrants a separate format, but the bulk of the challenge is understanding data and knowing where it needs to go in the final format.
Yeah, and David, I honestly feel like it would serve more of a custom transformer than it would as a format specific writer. That might help people get the data close to this format. But if you think about how many parameters exist inside of this feed, that dialog box, that custom transformer, you would have an incoming features, an incoming metadata info, an incoming data sources stream. And then aside from the 3 streams, you'd have 30 parameters to put into that custom transformer for which feature is linked to the value and the unit of the restriction and what's coming from the data sources and what the type of this restriction is and what column contains the direction. So it's certainly doable, but whether or not it would be able to be kind of normalized for everyone's data set is really where the question comes into play.
Good. Hey, Eric.
Yes.
Okay. Yeah, you want to make any announcement? Breaking announcement, breaking news?
Do I want to announce any breaking news? Do I?
I'm gonna make it though.
Well, I would feel more comfortable if maybe you said something.
Okay. Okay. Well, I'd like to announce that actually John is leaving FMET. He took an offer with Pima County GIS. Yeah, so won't be too far away, still in Arizona. So we still get to meet with each other in AGIC and what have you. So we certainly miss him. Yeah, so, and Eric and I, are thinking that we really like to have hopefully funding a DOT FME enthusiast, to be the host. That would be the best and making it a little bit more, DOT oriented, driven by DOT. And so if you know anyone who is interested or anyone in the audience and is willing to step up and, step up and help guide and organize this special interest group will be wonderful. We still be helping, facilitating certain things, providing the logistic support. Yeah, so
yeah,
and also spread word. Yeah,
right. And it's not that the DOT person has to do everything. It's just someone to help assist in getting some speakers, helping to moderate every so often, stuff like that. It's not a lot of work, but we really would like somebody from the DOT side to be involved kind of on our executive side of this group. So, and John, I'm sorry to hear that. Well, I'm not sorry. I mean, I'm glad that you got a job, right? But we're going to be missed. At least I got a chance to meet you face to face. I'm sure we'll meet up again. So, are you not doing any DOT stuff in your new thing or FME?
I'm sure I will.
Okay, all right. Well, that's good to hear. So, well,
yeah, I think
congratulations.
Pima County's transportation is one of the most important kind of GIS effort over there. They do roads and highway as well. So as a county, it's well run. Yeah, place ITGIS/GIS shop. Yeah.
So people like Kevin Hunt, need to step up and always.
No, he's just too busy now. We'll get him.
So
I want to contribute any way we can, but we know that there are some other states that are much farther along with FME and their implementations. So yeah, but look, want to contribute to this group however we can.
oh, we got
We're
Jenny.
excited about all the potential.
Yeah, Jenny from Connecticut has said would maybe be interested. So
That's terrific.
Yeah.
That's one of the states I had in mind.
So Eric, would you like to close this out?
oh well, I'll close this out. So well, thanks to everybody for attending today. I don't know when our next. I just closed the slide. Do we have something scheduled for next month or the month after? Oh, there we go. Next event, July 20th, 2022. Going to do HPMS validation with FME in Ohio. Yeah, that's right. We have Ohio DOT that's slated to talk about that. So that should be really interesting, especially those that are using roads and highways. So this will be a good one. And so that's what we got. So I'd like to thank everyone again.
Thank
Thanks.
you so much, everyone. This was really great. Great discussion too. Very helpful.
All right. And Jenny, one of us will get a hold of you and send you some information. So, and Bo, I can go ahead and do that. So, all right, I got to jump off to another meeting, but good to see everybody.
Okay, we'll talk later then. Yeah.
All right.
Okay.
Bye-bye.
Thank you.
Yeah.
Bye-bye.